All right, so in this video, we're going to go back to the unit circle. We're going to find the exact values of trigonometric functions using our unit circle. So suppose that theta is an angle in standard position. Remember, that means that it starts at our x-axis at 0 here. Let x and y be the terminal point of theta, meaning where it ends, right? Where the terminal side of theta intersects the circle. So that is our coordinate. Then the 6 trigonometric functions are defined below. So we actually looked at one just like this, but now we are assuming that our radius is 1. So we're having a radius of 1, 1, 0. That is what we're going to go with for these problems. Okay, so sine of theta is y, the y coordinate. Cosine of theta is the x coordinate. The tangent of theta is y coordinate over x coordinate. And then you would just flip these over for our right? So the cosecant is 1 over y. It's the reciprocal. And then secant is the reciprocal of cosine, so it's 1 over x. And then cotangent is a reciprocal of tangent, so it's x over y. All right, so, and we've used these before, but instead of having ones, we had r, because we could have any size radius. Well, now we're going to assume that it's a radius of 1. Okay, so that's the big difference here. Oh, a couple things that I did not animate all the way there. Suppose that theta is an angle in standard position whose terminal side intersects the unit circle at square root 7 over 4 and 3, 4. So we're going to find the exact values of tangent, secant, and sine. So if I'm looking down here, then tangent is y over x. So y is that 3/4 that we already saw up there for the tangent. And my x is negative square root 7 over 4. Now, remember, I can't divide a fraction. I actually have to multiply by the reciprocal of that number. So it's going to be, I'm going to multiply by 4 over square root 7. So if you notice, the 4 divided by 4, that's going to cancel. So I'm going to have 3 over square root 7. Well, I can't leave this. I do have to rationalize it. You can't leave a square root in the denominator. So I'm going to multiply by square root 7 on top and bottom. So it's going to be 3 square root 7 over 7. So that's my exact value. Exact value means I do not want to actually plug this into a calculator and get a decimal. I want to leave it this exact value with no rounding. All right, so now I'm going to do secant for my next one. So it's going to be 1 over x. So 1 over that square root 7 over 4. But remember, that means I'm going to multiply by the reciprocal because I can't divide like that. So it's 1 times 4 over square root 7. And I can't leave the square root 7. I have to rationalize. So I'm going to multiply by square root 7 on top and bottom. So I end up with 4 square root 7 over 7. All right, our very last one here is our sine feature, which is just the y coordinate, which is 3/4. So we don't have to do anything extra with that one. It is just all done. All right, we're going to try one more of these. So this is just a different coordinate here. So we can see square root 2 over 2 and square root 2 over 2. So now we're going to do that same pattern. We have tangent, and that's going to equal y over x, and they're the same coordinates, so they look the same, but we need to flip that over. We're going to multiply by the reciprocal. So if you notice what happens, 2 divided by 2 cancels, square root 2 divided by square root 2 cancels. So immediately I end up with just 1. So the tangent of this coordinate is 1. All right, so now we're going to go with secant. So I'm going to go 1 over x, which is that square root 2 over 2. So I do need to flip over, multiply by that reciprocal. So I'm going to have 2 over square root 2. But now I have to rationalize, right, just like we did in the last one. So I'm going to have 2 over square root 2 over 2. Right, well, 2 divided by 2 is going to cancel out, and I'm just going to end up with square root 2. Okay, so our secant is square root 2. And our last one, sine, is going to be square root 2 over 2, and I don't need to do anything with that. It is already rational. So that is all done. So that is how you find the exact value of your trigonometric functions using the basic unit circle. All right, hope that helped, and I will see you in the next video.